The relational model has three main characteristics. Firstly, let's talk about structure, which refers to the definition of content within. This includes attributes a relationship has and values contained in those attributes. For example, if we have a relationship with three attributes, it's just what we are talking about. For instance, let's consider a relationship involving a singer, like artist. In this singer-artist relationship, there is an attribute called name, referring to the singer's name, along with the debut part and nationality. These attributes can also include professions. For example, a name could be any subtitle in English or Chinese, such as Fei Wang, Yisen Chen, Jay Chou. Moreover, when referring to the year, it's likely just indicating that this 4-digit numerical can have a specific value. Additionally, this integrity also pertains to guaranteeing that the data satisfy these restrictions. For instance, as I previously stated, the year must be a numerical, and the name of the vocalist cannot contain any special characters. Certainly, there might currently exist certain instances, however, during the execution of this type of rigorous validation, we will encounter this restriction constraints, which encompasses various operations. In other words, how do we gain entry to and make changes to data within this relational model? This represents one of the three principal attributes of the relational model. Speaking of the relational model, first of all, let's talk about what a relationship is. It's actually an ordered collection that represents the connections between entity attributes. Because relationships are unordered, they can be stored in any way. And optimizing this storage method means deciding whether to use row storage, column storage, row-column hybrid storage, including other strange ways. Actually, any way is possible. Then we can optimize it further inside. So what is the actual relationship? If you were to map it to this relational database, or if you want a more intuitive understanding, especially just the table and all the legal data inside and outside the table, such as the table on the right is actually a relationship with the addition of its data to the tuple. In other words, you can imagine as a row of data in a table in the database. It is a collection of attribute values in this relationship. Originally, this value must be atomic, that is, it has atomicity, or it is a standard quantity. Its definition is very clear. Now, this value can be nested value in JSON. You can also store actual data in it. In fact, it's the concept of expanding attributes of this tuple in database development. Each attribute can also be stored. That is just me having an empty attribute. It means that this attribute is not defined. For instance, in my country, it can actually be empty, indicating that this attribute is defined in mathematical terms. It means that each element in my Cartesian coordinate system, referring it as an n-tuple, is essentially envisioning it as a row in a table within a database, encompassing its data. If you desire a more intuitive manner to visualize and comprehend the concept, let's move on to the next topic, which is actually quite easy to understand. In a database, everyone knows that if an attribute of a relationship uniquely identifies a tuple, is called the primary key. Generally, identifiers are used as primary keys because common attributes like names can have a duplicate. For example, there could be multiple people named Zhang Liang, or historical figures and current individuals sharing the same name, making it difficult to distinguish between them without a unique identifier. In a national database or any relational system, everyone's identification number serves as a unique identifier. This unique identifier can then be used as the primary key. In SQL 2003, for example, sequence, a keyword for primary key, and in MySQL, auto increment is a component primary key used to automatically increment this identifier, which helps clearly distinguish individuals, like 101 for Feiye Wang, 102 for Yisen Chen, and 103 for Jay Chou, turning these identifiers into unique primary keys. Additionally, there is a concept of a foreign key. A foreign key refers to an attribute in one relationship that must map to tuples in another relationship. For example, my attribute can refer to an attribute in another table, which constitute a foreign key. For instance, while artist ID 101 might lead us to Feiye Wang, if you attended the previous class, you would know about the album Stranger Under My Skin from 2011, co-created by Yisen Chen and Feiye Wang. This makes it difficult to ensure the uniqueness and validity of just one album ID, such as having both 101 and 102. To solve this, we create a mapping table between artist and album, which contains two keys. One is the foreign key corresponding to the artist, and the other is album ID, mapping to the album as another key, foreign key. For example, album number 12 could list both 101 and 102, indicating both Feiye Wang and Yisen Chen contributed to it. This table allows the foreign key to correspond both to the artist and the album. For instance, ID 103 shows that the artist is Jay Chou, with the corresponding album ID 13 from the year 2000. While primary key in one table is referenced as an attribute in another table, it automatically becomes a foreign key. This is crucial because these primary and foreign keys often appear together, allowing for complex relational queries. In some databases, this situation naturally leads to a join between the two tables, improving the reading speed by storing the join result as tuples or combining them in a way. In the next session, we'll explore how disks handle these configurations and how tuples are processed. We are going to define something within this relational model. We are going to define a database manipulation language, or DML for short. This DML is designed to access objects and data within the database using a programming language. There are two types of DML. These two types that do not coexist. The first type is procedure. This means that, for instance, the query specifies the DMS search strategy. The second type is non-procedure. This simply specifies what data is needed without defining the process of how it's fetched. SQL is a non-procedural DML. You specify what you need. For example, get an ID and a name from a table, but you don't manage how the system retrieves it. This approach is more typical of high-level languages. which are generally non-procedural and abstract away the underlying physical and disk operations. When designing a DBMS, we must consider these operations and optimize them for the front-end scenarios we are addressing. This involves deciding on a storage model, whether it is row-based, column-based, or some other method, and how to optimize this data storage method based on the specific scenario and data types involved. Lastly, I mentioned that the relational model being independent of any specific query language implementation. If we don't have a DML or if we don't have a DBMS, but I have a file and a bunch of data. In essence, this is a simple database. Earlier, when we defined the database, we said a database is just a set of entities. Let's take a look at the table on the right. We can query the data via Python script. First, we go through each line of file and assign the content to an array. When we find out the first element of the array is JCHO, we then print out its second element accordingly. For example, you can also use SQL to select data within a query line. Select year from artist where name equals to JCHO, which illustrates how SQL can operate independently from programming languages, making it easier for various programming environments to use SQL effectively within their systems. As you can tell, users can use any programming languages such as Java, Go to query the data via SQL. This is the separation of concern. Thank you, everyone. As you all know, CnosDB Cloud is alive. And welcome to join our Discord channel. And please feel free to discuss or raise any issue if you encounter. Thank you very much. See you next time. Bye-bye.